Так, дорогие друзья, значит, прямо сейчас у нас в эфире будет Джеймс Гослинг, отец Java. Значит, вести с ним интервью, которое плавно перейдет в Q&A-сессию, будут продакшн-директор JUG Ru Group Андрей Дмитриев и инженер в Amazon Web Services Фолькер Симонис, GVM-инженер с огромным опытом, долго работающий в SAP и так далее. Я потихонечку буду переключаться на английский. И... Окей, давайте нам выведем всех наших замечательных гостей вместе. Hello, gentlemen. Welcome to J-Point broadcast. Happy to have you on board here. And Volker, Andrei, the live is yours. Let's start, please.
Okay, so hi, everybody. Happy to have you here online. And I'm very happy and proud to introduce James Gosling, the father of Java. Just a very quick introduction because I think everybody knows him. So James was born near Calgary in Canada. He got a bachelor degree in computer science from the University of Calgary, then went to Carnegie Mellon University where he got a master and PhD. After which time he joined Sun Microsystem where he worked for 26 years, if I haven't mistaken, and where he developed Java, which is most known for. James got a lot of honors. For example, the Usenix Lifetime Achievement Award. He was made an Officer of the Order of Canada, became a follower of the ACM. He was awarded the IEEE John von Neumann Medal, and last year he got named a Fellow of the Computer History Museum. So this was a short introduction, James. First question, have you been to Russia before in person?
Yeah, I've been a couple of times. I've been to both Moscow and St. Petersburg.
That's nice. So we would have loved to have you in person at the conference, but in these hard times, it was unfortunately not possible. So nevertheless, thanks a lot for joining us here online. Maybe we can...
I'm happy to be here.
Yeah. Okay, so I will start with my first question. So what are you currently working on, if that's not a big secret?
Well, these days I work at Amazon Web Services. I'm in the IoT group. I work on connecting devices to the cloud. And that's about as far as I can go.
Okay. So IoT, that's already interesting, yes. So then which version of Java are you currently using? Is it 8, 11, the brand new tip version? And how are you using it privately or professionally?
I'm definitely using it professionally. It depends is kind of the sad answer. Mostly I try to stick to the LTS versions, which are 8 and 11. Play around with some of the others, but for real work, it's kind of you kind of have to use the LTS versions because they're the ones that are going to stick around. So as much as possible, I use 11. There are some places where I have to use 8, just because of, when you're kind of in the IoT world, a lot of them sort of stick still in the universe of JDK 8. So I need to fuss with that. And then sort of device coding, I mostly need to stick to the JDK 8 APIs, although I'm more likely to run on JDK 11. I play with the others, but it's hard to do anything professional with them.
So that leads me to my next question. Do you think then Java 8 will be around forever, that we will get a segregation in the Java ecosystems for the ones using 8 forever and the cool guys which go with the new versions?
Well, I don't think 8 will last forever. But it'll stick around longer than I'm entirely comfortable with.
Okay.
Yeah.
So,
Volker,
what do you think? Yes.
Volker, we have one interesting thing about. We should tell about that before we go further. Everyone who joined the conference, JPoint now. By the way, hello everyone who has joined. You can ask a question. If you type it into the chat, we can read it through and ask it in the live to James. If you want to join in our conversation, you can do it right away. By the way, after the talk, you can go to a the Zoom conference and speak to ask. If you want to speak to James, you can do that as well. But that's it from my side. Volker, please continue. Sorry to interrupt.
That's a good point. And actually, the first question, James, was what's the black hat in your back on the wall?
That was my question. I wanted to ask that. That's probably a hat of a sorcerer hat. So you put it on your hand before coding something.
No,
Oh yeah.
I went on vacation to New Zealand and had to do the required, Lord of the Rings studio tour, and ended up with this. So
that's one of the most informal interview I ever participated in. So great respect.
So we see. I see the next question here on the chat. So I will go with the question from the chat as long as we have question, and otherwise I will take the ones that I've prepared. So first serious question in the chat is: what do you think about Kotlin? Do you think it's a rivalry between Java and Kotlin? Do you think they will profit one from each other?
There's lots of stuff I like about Kotlin. It works well. I've done some projects in it.
That's also leads me to...
I don't think it's exactly a rivalry kind of thing, but mostly what I care about is the JVM, and that's one of the lovely things about the JVM is that it enables all kinds of languages to interoperate properly.
Exactly. And I had one of my last questions, which was really just for the case we don't get questions from the audience, was Java celebrated like 25th birthday recently. So the question would be, what do you think in 25 years, what will be more relevant, the Java language or the JVM as a universal runtime for arbitrary languages like Scala, Kotlin, or whatsoever?
Yeah, I think it's most likely to be the JVM. Although it's hard to tell. I mean, the Java language hasn't been getting. I mean, the Java language tends to evolve pretty slowly, and because there are so many Java developers and such strict requirements on backwards compatibility, it can be really hard to move forward. And so it's a lot easier to be nimble on languages that have smaller communities, and it's a lot easier for them to be a lot more innovative. Because it's easy to break things when there's nothing to break. And yet, the engineering team that looks after the OpenJDK has been doing some really nice work. The one I've been waiting for for years is value classes. I worked on that for a while, a long time ago, and it is super hard to do well.
Yes, so you touch all the topics I wanted to touch anyway. So actually, there's quite a lot of development going on in the OpenJDK project in the last few years. And I wanted to ask you about 4 specific ones. The first one you already mentioned, it was Project Valhalla and Value Object, but there is also Project Loom about lightweight threads. Then there is the Graal native image project, which you may be aware of, and the Panama project for better native interoperability. So which one is your favorite? You already told Value Objects. You think they will all...
Well, I'm from a nerdy point of view, I've really been a big fan of the whole notion of value objects. And, the problem with value objects is it's really hard to get the semantics right. To get the semantics right and really good performance. When I had this sort of joking conversation with some of the team folks, and I said, there's like 3 or 4 PhD theses in getting this right, and they said, nah. Well, it was mostly Brian Getz who said, nah. And the last time I talked to him about it, he was like, well, maybe you underestimated James. Maybe there are 6 or 7 PhD thesis topics. Because it's the sort of thing that you can get the first 95% relatively easily, and the last 5% will kill you. But they're getting there.
So maybe the Loom project, which is about lightweight threads, it's also kind of interesting, because when you started with Java, you had userland threads, so-called green threads that time. Then it was a great improvement when you moved to OS threads, and now the tension seems to go back to userland threads. So what do you think about this development?
It's all about developers' usage patterns, right? So back when we were doing the green threads, those got really great performance, and they scaled to really large numbers, and they worked quite well, and they were really absolutely necessary, because there were a bunch of OS platforms. Well, there was really only one OS platform where having a significant number of threads completely failed. On Windows, if we had more than a dozen real threads, the system would just completely fall over. And also in about the same era, Linux wasn't that bad, but it was pretty bad. But the problem with the user space threads was that the semantics of various things were just slightly off. So things like priority scheduling, the priorities and priority aging in particular were handled properly in OS threads, and rather raggedly in the userland threads. And there were times when userland threads would block in ways that you would find a little surprising, so that you could get these kind of semantic anomalies when a thread would sort of migrate back and forth between groups of sort of which physical processor was bound to, that kind of thing. And there was also this point at which the particularly Linux threads got a whole lot better. And Windows threads got somewhat better. So there was this general decision that, it was, we could solve the thread semantic anomalies without too much of a performance issue by just going to all OS threads. But in the worlds of people who are running thousands of threads, that's not a big problem. For people who are running tens or hundreds of thousands of threads, it's a problem. So, ta-da! We're back to the future.
Yes. Fine. So, one question from Nikita is, what is your favorite JAB? Do you follow the JAB process? There is quite a lot of JABs. I only mentioned a few of them, but do you have a favorite one which you're waiting for desperately?
I haven't been following them very much. I have to admit. I occasionally look at some of the language changes and get a little grumpy about like the way pattern matching was done. It's like tweak this there, and I occasionally, when the var keyword came in, that wasn't my first choice. Var. I don't know why. I mean, maybe it just, I'm showing my age, but whenever I see var, I think Pascal. And so I would have gone for a more concise syntax, but, the pattern matching stuff, that's all quite nice. I just would have done a less verbose syntax, maybe. It's one of those areas where I still miss Simula, and because Simula had sort of a type pattern match mechanism that was just ever so slightly cleaner, but it kind of had some issues too. So it's more you pick your poison. But since in my professional life I'm really stuck on the LTS releases, the latest hot greatness. It's curious, but doesn't actually. I don't usually get to take advantage of any of them quite right away.
Okay.
James,
so,
can we step back for several years and take a look on the early 19th, and let's talk about the Start 7 project.
Sure.
The Start 7, it's a very interesting project, and I just took a look. Please, who watch the video, who watch us, you can take a look in the YouTube video where James, back in 1992, I believe, or 1991, introduces a device, Start 7, which apparently communicates all the hardware in a house together. So, and the final seconds of that video, it's just 10 minutes long, so you can easily watch it tonight. There are several persons like Greg Forrest, Ed Fraser, Ed Frank, James Gosling, Patrick Nafton, and others. And you call that the green team. So I thought that, the green team, the green threads, behind the green door, so everything is green. Why you decided to call it green? Was it fancy name for those days?
No. This is going to sound really stupid, but we ran this project. We weren't in a Sun building. We had subleased some space in a nearby building, and so the door that went into our area was painted green.
Oh, that's easy. Oh, the question. The next. Go ahead.
Yeah. So it was really easy, because to enter our space, you had to go through this kind of funky green door.
Oh.
So we were behind the green door.
One thing you still remember from those ages, from the start 7 year, you still remember, you still have in your mind, and you use it in your day-to-day practice as an engineer. What do you have learned from that project?
Oh boy, there were lots of things we learned. It's hard to know where to start. And many of the things that we learned were not so much the things you would think, but because we were working with a lot of consumer electronics companies, and Java was in its original creation, it was for the IoT world, and one of the things that kept getting hammered into me was the extent to which reliability, security, code safety really, 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 really matters once you get things out in the world. So, so simple things like the memory model, the exception model. They're all about trying to make things that don't break. Right? There was an amusing article in, I think, CNET like a month or so ago, talking about talking about a study that some folks at Google had done about security issues in Chrome, and that they had sort of figured that about 70% of their security issues were because of memory corruption problems, dangling pointers, buffer overruns, that kind of thing. All the usual issues that you run into with the C memory model. And the thing that struck me as hilarious about that paper was that you could have written that 30 years ago. And I mean, that was the state of things 30 years ago in the C universe, right? That so much of the reliability issues and security issues were entirely because of memory integrity problems. And that was one of the things that really drove the design of Java, was to make it so that there were large swaths of problems that you just couldn't do, right? So in the early days, people were really grumpy about the fact that they couldn't turn off subscript checking. And it's really important that you can't turn off subscript checking, because as soon as you turn off subscript checking, then you've created a huge security hole. And the usual complaint about subscript checking is that if you do it, it slows things down. But modern compiler technology is smarter than that. So almost all subscript checks can be theorem proved out of your code. And certainly Hotspot does that so that your code behaves as though it's doing subscript checks everywhere, but it's not actually. And, in going around to embedded device customers, they never really talked about, on their requirements list was never there was never like a reliability line. It's kind of like the assumed requirement 0 was thou shalt not kill your customer. And, in the computer business then, people were perfectly happy to accept slightly flaky results if they could get them a little faster.
James,
it's actually interesting, James, that you mentioned that Java was actually first intended for Java for IoT devices. And Nikita has the question: what do you think about Java ME, which is almost dead today? So do you think that Java or the current Java SE is still a good fit for IoT, or do you think we need a new platform or a new technology for that?
From my point of view, the thing that killed Java ME was Java SE. Java ME was all about fitting into really tight spaces. Java SE, like on a Raspberry Pi, Java SE runs with gobs of leftover space. It's, on a Raspberry Pi, it's a drop in the bucket. There's, the thing about embedded devices is you can't see what programming language was used on the inside. Before I came to Amazon, I spent 6 years working on an autonomous robot, and it has some relatively sophisticated AI components, and that turned into like needing really complicated data structures. And I wouldn't have wanted to do that any other way than in Java, because it was, a complex series of analyses that interacted with, there's like all these sensors, and, you're trying to do collision avoidance and trying to, keep a view of like what the situation is around you, how to respond, especially when there are, multiple things going on. And, in that case, it's a device in the ocean. So you never get to stop because you can't just like turn off the waves. And so you really have to push on reliability, and you really have to make sure that all the complex stuff works rock solid, and it worked really, really, really well.
Was it actually surprising? We saw that Java was initially designed for like embedded IoT scenarios. Then it was a long time marketed as for in-browser applets or desktop applications, cross-platform. But in the end, I think it was most successful in writing server-side application servers and stuff like that. So has this been surprising for you?
Well, sort of yes and no. I mean, certainly when Java was started, the app server thing, nobody thought of that because nobody was doing it. I mean, there were no app servers in the early 90s. So, but, the first the first Java app server started to run in very early 95, maybe actually late 94. And it worked really, really well. I mean, Java is a very general purpose programming language, so you can kind of do whatever you want with it. And, that turned out to be a big strength. And, any programming language pretty much goes wherever its users take it.
So what do you think, why Java failed on the desktop? I mean, there have been several approaches. AWT Swing was very successful in the beginning. Then we had SWT, JavaFX. But nowadays, it seems there's not used so much. It's all done in the browser or with Node.js Electron frameworks or stuff like that. So Alexei wants to know, do you think there is a future for Java on the desktop?
I have an addition to that because in our chat we have another question about the do you see any chance for Java to conquer the web area once again, like applets version 2, for example?
All of these questions are not even vaguely technical, right? The Java on the desktop thing became almost entirely a matter of politics. Once you get people like Apple and Microsoft in the mix, things just get really, really messy, right? So, Apple has never thought that interoperability was a good idea. They really like having a closed ecosystem, and I love Apple. All the computers in my house are Mac machines, but Windows, it's the same kind of deal, right? Microsoft works really hard to steer people to stay within their ecosystem. And the desktop apps are one of the places where sort of ecosystem control is the biggest deal. But the IDEs that most people use, there's Visual Basic, but the other ones, NetBeans, Eclipse, IntelliJ, they're all Java desktop apps. And the applet thing was there were technical issues around the Windows desktop. If one was to revisit that whole sorted story with today's browsers, it would be a whole lot easier. And if you you can't look at any of these things from a technical perspective and understand anything, because it's all a playground filled with children throwing mud at each other.
My turn, right?
Yes,
Walker, what do you mind? Oh,
yes, please. Go ahead.
Tonight I'm a funny person, so my question's more like non-technical. So please be prepared for that, James. Sorry in advance for that. The JUG, the well-known Java mascot, it was created by Job Pallang in 2007. It was open sourced. It's BSD licensed. Do you feel anything related to JUG character? Because for me personally, for all the Java ecosystem, for every single Java developer, JUG is a kind of a symbol of, I don't know, a symbol of epoch, a symbol of Java language. Do you have any personal feelings to that person?
Yeah, definite affection. I mean, you know, the original design that Joe did was all about, you know, trying to make something that was fun and friendly and, you know, worked well at small sizes. And, you know, as mascots go, he's been a lot of fun. People have done all kinds of things, you know, drawing images with him and adapting him to pretty much any sort of purpose you can imagine. So yeah, he's been fun.
Great. So I have two related questions here from Ivan and Alexei. So Ivan wants to know what's your favorite Easter egg in the Java language, and Vladislav wanted to know what you consider the biggest mistake which was done in Java language or VM. So maybe these questions are a little related. So can you speak on that?
Oh boy, there really aren't any Easter eggs. You know, most of the things that are kind of in that category, there was a lot of stuff that was inherited from C because, you know, one of the goals early on was to be sort of culturally compatible for people who had been programming in C. You know, so things like the cast syntax and the instance of syntax, things like the XOR operator. I actually got to use the XOR operator in a piece of code like a week ago, maybe 2 weeks ago. And, you know, it's like taking up a whole operator character for something that almost nobody ever uses. You know, grep for the XOR operator, you'll find damn few of them. But it's there kind of for completeness. Yeah, you know, so sometimes I think that it would be fun to do, you know, instead of trying to build a language to appeal to a large community, you know, I sometimes think it would be fun to do one that just appealed to me, you know, and most people would be horrified if they saw that. But
so you mentioned that you worked on underwater robots for quite some time. So Evgeny wants to know if you had any issues with garbage collection in such an environment and what you did about it.
No, we didn't have any issues with garbage collection. I mean, you know, the thing about garbage collection is it becomes a problem if you've got large heaps. But when your heap is 20, 30 megabytes, 40 megabytes, I forget what it was, GCs happen really, really quickly. You know, it's there, you know, a small number of milliseconds. And the stuff that had really tight timing issues was all in, you know, firmware and device controllers, you know, on the sides of motors and that sort of thing. So within the robot, if there were time bobbles of like half a second or so, there was no big issue. We could even take a longer one than that. But yeah, GC was never even noticeable as an issue. Okay. And that was using a fairly old GC. The modern GCs are much better.
I have
so, Andrei, your next question.
Oh, thank you. I have a question. It's related somehow to a question from a chat. That's actually my question, but anyway, James, what do you think about, can you please imagine or share with us what was the most annoying thing introduced in Java? I mean, what have been done so amazingly incorrectly during the development of Java, design in Java? And moreover, Vladislav, he asks, do you think that you can, and the whole dev team could develop the design of checked exceptions in some other manner, which looks like a little bit contradictory at the moment?
I don't know where to go there. I mean, most of the things that annoy me are in the libraries. And many of the library things that annoy me are ones that got rushed rather than really thought through. So like the design of AWT really became this kind of lowest common denominator thing, which made me laugh when the Eclipse folks did SWT, which was pretty much an AWT clone.
By the way,
yeah, I mean in Java itself, it's I guess the top of my list of things to hate is casts.
Casts. Okay.
Yeah.
By the way, I used to work for Sun Microsystems for several years, and guess which team I was part of? Volker knows for sure.
Yeah.
I was a part of
the DCK team?
No. I was a part of the AWT team for a while.
Okay.
So when you said that one of the big mistakes in Java was libraries, in AWT in particular, I said, oh, shit, sorry for that.
Yeah, well, the thing about AWT wasn't so much, I mean, the way that the event model sort of got pushed by, as soon as you try to do something that is sitting on top of the platform components, like it had to run on the Windows UI and it had to run on the Unix UI libraries, and it had to run on the Mac UI libraries. All of them do things a little differently. And getting something that would work here and work there and work in that other place using their platform facilities, when many of them just like fundamentally did things differently. And, the place that was the hardest to deal with was event dispatching. That still pains me. Right. And then of course we got to redo it all when we did Swing. But of course, even though we did Swing, we couldn't delete AWT because there was an awful lot of people using it.
Somebody thinks that they still can't delete AWT from Java because it's existed for so many years. So it's a piece of respect to that old library to keep it there. To be serious, the whole concept of Java was a little bit weird because Java is stated to be write once, run everywhere. Similarly, but at the same time, when the AWT was introduced and after that was covered with the Swing UI, they said it will work natively, which contradicts to the first statement. So far, my next question is, let me check. In one interview, you said that the engineering is all about the trade-offs. It was about 10 years ago. You have given in some interview, and many years ago, Java was a game changer. Many years ago, cloud was a game changer. But do you think that the Java and JDK and the clouds, they're kind of magic? They change the game, but on the other hand, it's just an engineering practice. And someone, you, maybe some other guys, maybe JetBrains, maybe AWS, they could invent something new. They could create new JVM. And it could become a game changer. So where is the difference between the engineering practice and the game-changing solution?
You can never intentionally change the game. I mean, you might wish to change the game. I mean, I live in Silicon Valley, and it's wall to wall with people who claim to be changing the game, and mostly it's a marketing slogan. You can only decide that you've changed the game retrospectively. And if you go out with the intention of changing the game, you'll probably waste your time on silliness. The thing about engineering is that it's all about solving problems. It's all about fixing issues that, cars are trying to cross a road, so somebody should build a bridge. Games change when problems pile up that are just calling for a solution. And if you've got a solution that covers a broad enough set of issues, then you can change the game. And one of the things about Java is that it changed. It made a difference in a lot of different ways. I could go and talk to people and say, what do you really like about Java? And they'd say X, and the next person I'd ask would say Y. And, there was usually like a dozen different answers that people would give. But there wasn't just one answer. And so kind of checking off a whole lot of boxes means that it does something really important for everybody. And you can't just wake up in the morning and decide I want to change the game. You've got to wake up, you've got to say, gee, there's this problem and this problem and this problem and this problem. What are the commonalities? Can I, solve more than one problem at once? Once you see what the issues are, sometimes, really radically different solutions present themselves. If you look sideways at Java, there's really very little invention there, right? It was harvesting a bunch of ideas that had been around in the computer science academic world for a long time, but just never made it mainstream. So things like threading, right? I mean, threading had been around for a really long time, but Java was really the first language where threading was easy to do. Garbage collection. Most people thought of garbage collection as something for lazy software developers who don't want to take out their own garbage. And it's like, no, it's a lot more subtle than that, right? And then you package that up in a way that fits in with engineering practice rather than just being, a line item in a PhD thesis. Because all these things, they don't go anywhere unless you reduce them to practice somehow. And it's a lot of work.
So maybe come back to a more technical question. User Sabbat wants to know, what do you think about GRAL, native image? There's a lot of fuss nowadays about building a native image of your Java program so it has fewer resource consumption, faster startup. But the drawback is, as you say, you always have to trade. The drawback is, of course, that this takes away a lot of dynamic possibilities which Java has, like dynamic class loading, bytecode generation at runtime, reflection, stuff like that. Do you think that it's a valid trade-off to take away? Do you think Java doesn't need all these dynamics, and it's worthwhile doing a new version of Java which can be statically compiled more easily?
I am deeply addicted to most of that dynamic behavior. I started using languages that have that kind of, Java's form of dynamic behavior, at least 40 years ago. And I've been hooked ever since. And so, mostly when I build things, they're dynamics somehow or other. Often, the basic frameworks that I like to use with are all ones that accept plugins. You can build extensions for stuff. And reflections and annotations. The things you can do with that are insane and beautiful. But things like annotations and reflection, you can actually build static compilers that do a decent job of that. For things like class loaders, you can actually do that by both having statically compiled code and having a JIT, or just interpreting dynamically loaded code. That has horrible implications in terms of code size and performance. But nonetheless, there are definitely situations where static compiles make a lot of sense. If you don't happen to be using much dynamic behavior, or if you can do a static compile where you can say, statically compile these things, even though you can't actually see references to that. Using class.forName, just trust me, it's going to be used. And most static compilers have facilities like that. But the optimizations that the hotspot JIT is able to do, it's really hard for any of the static compilers to handle. And so if you've got like long running programs, it's really, really hard to beat the hotspot JIT. But nonetheless, and actually for somebody like me who does a lot of embedded work, the static compilers are a really big deal. And there are a number of them around, of which the GRAL static image generator is just one of many. But it depends on the situation. Mostly you don't actually need the static compilers. Maybe sometimes it helps with startup, but if you've got a long running app, the like 100 milliseconds you save don't actually matter.
James, we have a next question in our chat. I can't ignore that because this question comes from Nikita Lipsky, who worked for Excelsior Jet company. It's a well-known company who produced the ahead of time compilator for some time ago, and he asked some interesting question. Please take it carefully. Do you think it's time to make a revolution and to fix all the Java issues that can't be fixed before due to historical means probably backward compatible reasons? So are we talking about the Java 3.0, Nikita? Yeah, James, go ahead.
Yeah, so sure, you could break everything, but then the literally millions of Java developers who are using all these tens of thousands of packages out there, they'd be starting from nothing, right? I mean, one of the most powerful things about the Java community is that there are some amazing libraries out there. In my previous life, I loved having access to libraries that would do things like astronomy, right? You need to be able to do astronomy if you're going to do navigation. You need to be able to do all of the spherical trig library stuff. If you've got solar panels, astronomy is really nice for being able to tell you, like, where is the sun and how much power should I be seeing, and I'm not seeing enough power because so maybe it's foggy, or maybe a seagull just shat on my solar panels. And libraries for computing the effects of the Earth's geomagnetic field. Yes, that library exists and it's wonderful. And how many people in the audience have actually ever used the geomagnetic field library? And if you start breaking things, then all of that stuff goes away or has to be rebuilt. And I'm professionally, none of the things that annoy me about Java are worth giving up the things that I love about it. Every now and then I'm mad enough to think that it might be worthwhile. And the JVM based languages like Clojure and Kotlin and all of that, they preserve all of that stuff. Once you try to go to languages that really depend on sort of static compilation nature, then you end up giving things up. If you do things like change the call sequence for a method, then things get deeply broken. So it's always a balancing act.
So maybe a quick, more general question from Anastasia. She wanted to know what resources you use to stay up to date, like professional-wise, computer science, programming-wise.
Well, in case you hadn't noticed, it's pretty much impossible to stay up to date with everything. There is if you really tried to stay up to date with computer science, your head would explode. There is just so much stuff. I mean, if you just take one thin slice of it, like machine learning, you couldn't even cover machine learning. So I don't have a strategy for keeping up to date other than just reading everything I can. If somebody, sends me an email saying, hey, this is really cool, I go and I read it. Finding sort of nerdy websites that talk about, breaking news. I use Slashdot more than anything else. But, the Slashdot crowd, it can be deliciously cranky, which is one of the fun things about it. But just the fact that everything is online, the fact that, everything is one Google search away, and I just read all day.
So maybe also
you wanted to ask a question about the Emacs, right? We have talked about the Emacs. Emacs.
Yeah. Yes, exactly. So maybe few people from the audience know that you wrote your own version of Emacs once upon a time. So just wanted to ask you, do you still use Emacs for daily programming, or do you use one of the more modern IDEs like NetBeans or Eclipse or Visual Studio Code?
Look, the Unix Emacs that evolved into what's now GNU Emacs was a really good idea in 1977, 78, right? And Lord, isn't there something we can do with the 40 odd years of Moore's Law? So I am a huge believer in IDEs. I mostly use NetBeans. It's like everything that you could think of in NetBeans, I deeply love. Having essentially lint running continuously, command completion, really good debugging support. I don't sort of type my way to code. I tend to refactor my way. I'm a big fan of all the refactoring tools and, the auto-indenting stuff and all the creature comforts that are in the sort of typing facilities, and, the fact that it's always compiling in the background. The fact that all, when you're working on 100 different code modules, it's cross-checking all of them all the time, and you see the errors sort of pop up as you type them. The really fast feedback that you get is a huge deal. And these days, tools like Emacs and VI, they feel like, banging rocks together. I tend to use VI a fair amount, but mostly because VI is installed by default on absolutely everything. And of course, there have been modern replacements for VI, and they tend to all be called VI. But the same sort of muscle memory commands carry over. And, VI works really well when you're SSH'd into something and there's nothing to install. It's just there always. It's a universal constant. But when I'm really coding, it's always NetBeans.
So assume you had unlimited resources like time and money-wise. Is there a project you would start now?
Yeah, that's kind of open-ended, find a cure for cancer, solve global warming, the COVID crisis.
Okay.
For me, programming is all about solving problems. There are a pile of things that don't get the kind of attention that they ought to get. Like, I've always been kind of cranky about how hard it is to get anybody to do really good tooling for scientific programming. Because most scientific programming these days kind of sponges off of what happens in the sort of enterprise computing, and probably most important is gaming. Modern hardware wouldn't have decent floating point if it wasn't for gaming.
James, we have a funny question from the chat. Vladislav, he has two questions. One of them is about your favorite book. By the way, you have written several books, and you participated in many books as an author about Java and Java technologies. Do you have number one book you could recommend to all our watchers tonight?
I can't really recommend a Java book because I haven't read one in years because it's all online. If you're looking for sort of a general programming book, boy, there are so many of them. There are some classics that I still love, like John Bentley's Programming Pearls, or Sedgwick's Algorithms book, Josh Block's. Anything by Josh Block is worth reading, or anything by Doug Lee is worth reading. There's just so much of it.
And the next question from, it's quite funny, but you should know the answer. When you compile a program on Java language, if the compiler asks you for a permission to compile your code or not?
Why should it ask permission? You've just told it to compile the code.
No. I mean, if you make a mistake in your code, the compiler knows that you're James Gosling and the creator of that compiler, for example, with that language, if it asks for permission to compile it or not.
I make mistakes just like everybody else. I'm dyslexic. The number of typos in my code first time around is huge. That's one of the reasons that I like using an IDE, because it gives me almost instantaneous feedback. I am a normal mortal just like us all.
Nice. Thanks for the answer. We have 2 minutes left, and Volker, I have one more question, and then we're gonna go to the bottom line. Okay. The question is pretty short. What motivates you in your daily life?
Boy, what motivates me? I like to play with toys. Of course, my definition of a toy is maybe different than most people's. I like to build stuff. It kind of doesn't matter what I'm building. I just like the act of building. Things that I've kind of hard for me to. My office where I'm at is sort of wall-to-wall stuff. It's really quite a mess. I think I've got like a dozen computers here within eyesight. But they're just fun.
Okay.
Yeah.
The bottom line for today before we're gonna go to the questions and answers, sorry to hear that. The question and answers part of this talk. The bottom line for today. First of all, the breaking news from JPoint conference: James uses Kotlin in his projects.
Well,
Everyone should know about
I have used it. Right, the projects that I'm working on right now are pretty much all Java.
Nice correction, very important. The next breaking news.
But I've also done projects in Scala and Clojure, and lots of other things,
Nice.
right?
Nice. The next thing is James started IoT projects even before in those ages, even before the IoT term was invented. And the last thing, very serious, I even can't smile during pronouncing that. You can't make a game-changing thing intentionally.
That's
This is
pretty
it.
much the case.
I see that bald person on the left, and he's probably asking us to finish up and wrap up.
Yes, James, I've sent you a link to the Zoom meeting, so you can meet some of the participants in person there when you click on that. So I think with that, we're finished here in the video conference, right? And,
Alrighty, and I see that, so I will meet you all there.
Yes. Okay, so thanks a lot.
Okay, gentlemen, thanks a lot. Thanks, Volker. Thanks, Andrei. And thank you very, very much, James. This is a great honor for JPoint to have you on board this year. That's amazing. Thank you very much.
Yeah,
Thank you. Thank you.